I'm Greg, lead developer advocate at Hedera Hashgraph, and this is the first part of our API.
So the Hedera API, which we call HAPI, obviously, covers the cryptocurrency service, the file service, and the smart contract service. So some kind of underlying detail behind the API and how it was built, and some of the thought processes behind it as kind of background information, if you want. So it's built on protocol buffers, which we often refer to as protobuf, and I'm sure the rest of, or others within the developer community does as well. The quote I've taken here is directly from Google's own protocol buffers website. It's a language-neutral, platform-neutral, extensible mechanism for serializing structured data. Think XML, but smaller, faster, simpler. When we started looking at API requirements for Hedera, there was a strong desire to make sure that the data payload, if you want, between the clients and the nodes was as lightweight as possible. 100,000 transactions per second is an awful lot of data potentially, and every byte that you can save means a lot at the end of the day. So messages in protobuf, both request and responses, are defined as messages containing data. And further to defining messages, we can define remote procedure call type patterns such that a request and a response are predefined. Transport can be over HTTP or other mechanisms, as far as I understand it, but this is kind of to a certain extent below what we control. I understand that we're running the remote procedure calls, gRPC, over HTTP. And messages can be nested inside each other. So when we're looking at some messages later on, you'll see that we define things like an account ID, which is made of three numerics. And that account ID message is then used, peppered throughout the API wherever an account ID needs to be used. So that level of reuse is highly useful in ensuring some level of consistency, if you want, within the API specification. So let's look at some protocol buffer message definitions. Messages have a name. So in these examples, I have a message called account ID, and I have another one called crypto create transaction body. Bit of a mouthful, that one. And now we call them, well, or protobuf calls them messages. To me, they're kind of data structures to start with, and they become messages when you exchange them between two endpoints. So you can see account ID as a message could be exchanged between a client and a server, but it's also used as a proxy account ID within the crypto create transaction body. So they serve both purposes. One of, as I said before, reusable message structures or definitions, as well as natively being able to be exchanged between systems. So let's look a little bit further on. We have some data types within protobuf. So double float, integer 32, unsigned integer 3264, Boolean, string, bytes. There's a whole bunch of likely candidates for data types. Enumerations, repetitions. So you can have in the search response, for example, repeated results. So that infers that the result message can be repeated within that response. And also selection, one of, meaning that a key, for example, is one of a contract ID, an ED25519, RSA, ECDSA, threshold, or key list. So quite a lot of flexibility within the message definition here, or definitions. The RPC service, or gRPC, define operations and request response patterns. So if we look at the crypto service, there's an RPC create account, which takes in a transaction and returns a transaction response. An update account takes in a transaction and returns a transaction response. A query or get claim takes in a query and returns a response, and so on and so forth. So this is useful for kind of defining request response type patterns, which are not otherwise obvious when you're looking at the protocol buffer messages. They're just a collection of messages, and only the wording of crypto create might infer that this is for creating something, but you don't necessarily know what response you will get from the server. So those gRPC services help us define those patterns. Having defined all those messages, we can compile them to a number of languages, either supported by Google or third parties. So yes, you can compile these protobuf messages, which will generate codes that give you methods and functions for creating and reading protobuf messages. We can see on the left-hand side an example of a message duration compiled to Java. Gives you this duration.new builder.set seconds, so I can set the 150 seconds .build, and that generates me a protobuf message that looks like transaction valid duration seconds 150. In actual fact, when this is sent over the wires, it's 3 bytes. There's a huge amount of, it's not just compression, but data mapping, if you want, that goes on, which makes it highly efficient. If you were to do this in JSON or XML, all of that text would have been transferred. So the savings here in terms of bandwidth are very significant. And Google use this throughout their infrastructure. So it's quite good. Right. So let's look at the API. So the API is made of transactions and queries, as we've kind of covered already with crypto economics and so on. So transaction, similar to a method, is sent to the network for consensus. Fees typically are applicable. Queries are only processed by the receiving nodes. There is no consensus. And a few of them are free, and the others are subject to fees. A transaction in itself consists of a transaction body and signatures. The transaction body contains the details of the node's account to which so this is the cryptocurrency account reference, if you want, of the node receiving or to which the transaction is being sent. The fee for that transaction that's being paid for by the client, the valid duration for the transaction. So a valid duration introduces some interesting use cases potentially. Let's say that I offered somebody a particular service or something for up to 24 hours. I can generate a transaction now and give it a valid duration of 24 hours. I can send that transaction onto the third party to sign. And if the third party signs and then submits the transaction outside of that 24-hour window, the node receiving the transaction will reject it because it's no longer valid. So the valid duration can give you some interesting use cases, as I said. Besides simply sending a transaction to the network, you can already start to build almost some logic around that duration. The body also indicates whether a transaction will generate a record. That's a Boolean, and we'll talk about records and receipts a little bit more later on. So I'll leave that for now. The transaction also contains a memo. That's 100 bytes of data. Any data you want, a bit of text or even a hash of something, any data payload you wish. It's optional. You don't have to put it in. And then the type of transaction that's specific to that request. So are we creating an account? Are we creating a file? Are we running a smart contract function? That's where the transaction itself goes into that body. And then the signatures for the transaction, we'll talk again about keys and signatures in more detail, but every transaction and virtually every query has to be signed because there is a fee that needs to be paid. So let's look at transaction in protocol buffers. It's, as you see here, the message definition is that of a transaction body and signatures. The transaction body itself is a transaction ID, an account ID, the transaction fee duration, the string memo, and then the different types of transactions. They're not all there. Those slides were written some time back. There are a few additional transactions now. The type of transaction that, as a one-off, that can be submitted into that transaction body. Queries. So a query, as I said, only goes to a node. It doesn't go to the network for consensus. There are 4 types of queries. One is an answer only. So essentially, just tell me the answer to my query. The second is an answer with state proof, which means give me an answer, but also include a state proof for that answer. So for example, more specifically, any entity within Hedera Hashgraph is subject to state proof. So let's say I've created a file 3 weeks ago, and I want to prove to somebody that file exists and it has a certain size, for example. So I could do a query called get info on the file with a state proof, and that response I will get from the network will be all the file details associated with a proof of that file existing on the network with the properties of size and so on and so forth. And there will be tools available to decode the state proof to prove that it indeed came from Hedera Hashgraph. So that's as good as bulletproof when it comes to proving something has happened or does exist on the network. So has happened could be a state proof for a transaction, which is a crypto transaction is by necessity transient. It occurs and then it kind of disappears. It no longer exists if you want. But a file or the state of a smart contract or the state of an account and its balance is subject to state proof. It's an entity that you can generate a state proof on. The third option for a query is a cost for answer only. So you may want to ask how much would it cost this particular for this query to be run. So you will get the cost answer, and you can also run a query to get the cost for an answer with a state proof. So there may be some queries which will be fairly large. There is one, for example, is get account records. If that were to return 1,000 records, this could be a fairly expensive query to run. So you may want to do a cost for answer only first, and that will give you the cost of running that particular query, which can be calculated by the SDK or by simple tables, because the size of the response will depend on the number of records and so on. And then the query itself specifies what is being queried. So is it a crypto get balance, a get record, get info, and so on and so forth. Okay. So here's a complete get balance message as defined or as kind of crafted through protobuf. it normally looks linear, but I've had to kind of make it fit on the screen. So we're doing a crypto get account balance query. It has a header, which includes a payment. That payment has a body, which contains a transaction ID, because this payment is actually a crypto transfer transaction to pay for the get account balance query. So the body contains a transaction ID, and this transaction ID you see here, the valid start and the account number or account ID are the unique identifier for this particular transaction. Other systems have nonces and all sorts of ways of uniquely identifying a transaction. This transaction ID is how it's done for Hedera. So it's seconds or a timestamp and an account number. The node account ID that or the account ID, the crypto account ID of the node we're sending the transaction to, the transaction fee, the valid duration, so this is valid for 2 minutes. Do we want to generate a record? Yes, the memo. And then the transfer, and you can see here that we're transferring from account 1038 minus 10 tiny bar, and we're transferring to account number 2, 10 tiny bar. All this is paying for the transaction, 10 tiny bar. As you can tell, this is not how, well, those of you who know the SDK and have used testnet and mainnet recently, it's 100,000, it's not 10. Then there are signatures. So the signatures here are those of the account 1038, paying for this 10 tiny bar to the network or to the node. So obviously there is an outgoing amount from this account, so it needs to be signed. Else the network will refuse the request. And then the account ID that we're querying, 1038, this could have been any other account. It could have been 1039. So 1038 pays to query any account number that it wishes to do so. Now, you may see things in here. For example, we don't see, so an account ID has a shard and a round number. Because they're 0, and 0 is the default value for those in the protobuf message, they're not included in the message itself. So again, this is Google's way of reducing the payload by removing anything that's default, anything that's not necessary from the message itself, and making it as lightweight and data efficient as possible. So that's what a complete get balance message looks like. Right, keys and signatures. Before we get into more of the API details. So keys that Hedera supports right now are ED25519 and contract. A contract can act as a key, and essentially that means a contract can sign a transaction for something that it is responsible for. Keys can contain or can be a key list. So one of the key features here of Hedera Hashgraph is its ability to be multi-sig out of the box. So if Andy, Andrew, and I, who are on this call, wanted to set up a common fund, and all three of us wanted control over outgoing transactions from the account, we could set up a key list, a multi-sig account. And all three of us would have to sign for any outgoing transactions from this particular account. Moreover, we have key lists with thresholds. So those are same as a key list, but where only n of m signatures are required. So taking the same example of Andy, Andrew, and myself having an account, all three of our keys could be in that threshold list. So we're all account holders, but we could have a threshold key list of 2 or 3, meaning that only 2 of us need to sign an outgoing transaction. The third person is not required. So this can be, so as I said, this is native to the platform. So wherever you previously would have had to have a smart contract to manage multi-signature, you can do this at the API level natively. And they can be nested. So you can create some relatively complex, I think the maximum depth is, no, I won't say because I can't remember specifically. There is a limit to the depth you can go to, but it's high. And you can nest keys and key lists and so on and so forth to create key structures that might represent how a business is operating. So if you think about an enterprise with a marketing department, a financial department, an IT department that have to approve several purchases, there could be an account with the key lists or the keys set up to mirror those organizations, maybe with threshold lists inside some of them, such that any outgoing payment has to be signed by the requisite sort of company departments or people therein. So that's keys and signatures at a high level or an introduction. So I've covered keys, key list as a list of keys. I apologize. That first slide I usually use as an introduction to the API, and I don't normally go into the detail that we have today. So I think I've said most of the things you'll see here. The key list is a list of keys, can be used to secure an account, a file, or a smart contract. All keys must sign transactions with no exception. So you can see the protobuf message here, which is a repeated key. And we don't have to use smart contracts for multi-sig. A threshold list or a threshold key is just like a key list, but we have this additional threshold. So it would be 2 for 3 or 2 out of 3. And this enables partial approval of transactions. So this is an example of signatures or associated, example of a complex key structure with nesting. So you can see keys that contain a key list, which contains a bunch of single keys and a threshold key. So in this case, the top 3 keys must sign a transaction associated with this key structure for a given entity. And 3 out of 4 have to sign from the threshold key list, as well as the top 3 keys. Okay. And this is how the signatures would look. So signatures have to match the key structure. So I have to have signatures on the left-hand side for the top 3 keys. And as the threshold key at the bottom has a threshold requirement of 3 out of 4, key number 2 has decided not to sign, and that would still result in a valid signature. Now, there is a comment at the bottom here. If the same key appears twice, it needs 2 signatures. That was true. We're working through improvements to the signature process or the signature part of transactions where it will only be necessary to supply signatures and a uniquely partial public key for each of the signatures, and the network will take care of reconciling that the right signatures exist for the right keys, which makes it easier to construct those signatures. There will essentially be a sort of a key value pair, if you want, of public key and associated signature, which will make it much easier to manage from the clients. But the principles remain the same. You have to have those signatures for thresholds and so on. So let's look at the cryptocurrency service in lots of detail. So keys for transfer out. This is not, I guess, unnatural or unusual, but transactions to transfer coin out of an account must be signed by the key holders. That's fairly straightforward, and I won't go into any more detail on that one. Proxying, we've covered already. You can specify on a crypto account which ID of an account you wish to proxy to. Now, the ID of an account in Hedera is a shard number, a round number, and an account number. It's not just a public key. Remember, we have multi-sig out of the box, so that's multiple public keys. So an account has to be identified independently of the public keys or public key that represents it or that secures it. So an account ID, and this applies to file IDs and smart contract IDs, are a combination of a RAM number, a shard number, and an account file or contract number. Thresholds. We looked at, or when we looked at transactions earlier, there was an option to generate a record as part of a transaction. But I can set up an account through thresholds such that a record is generated by Hedera automatically when an outgoing crypto transaction or an incoming crypto transaction exceeds a given threshold. And the send and the receive can be different thresholds. So even if the originator of the transaction didn't specify that they wanted a record for the transaction itself, the network will generate that record automatically on my behalf if any of those thresholds have been broken. So you could have it set up so that anything over 10 or 100 HBAR automatically generates a receive or a send record threshold, and maybe anything over 1,000 HBAR has an automatic receive record threshold, so that you can later prove that those payments have been done. Receiver signature. That's an unusual one. I don't know that there are any other networks that have this capability. This enables you to essentially say, when I receive funds, or before I receive funds, or any transaction that sends funds to my account, I need to sign for. So if you're a non-governmental organization, an NGO, or a politician, or any public-facing organization with a HBAR account or a Hedera account, you will likely be under some scrutiny, as you would be with a fiat account, as to where the funds are coming from. Where are you getting paid from? So a receiver signature allows you to basically say, well, I am not accepting any payments into my account unless I sign them, which means you can validate incoming payments. And if you're happy that those payments are coming from a source that's acceptable to your ethical policy or otherwise, then you can sign the transaction and the payment will take place. So that's what receiver signature stands for. And again, potentially lots of interesting use cases around that, or maybe a way to attract non-crypto or people who fear crypto to Hedera Hashgraph because of that capability. The auto-renew period for an account is related to the crypto economics. So an account that exists on the platform has to pay for itself in order to remain on Hedera. This is to account for the resource utilization of that account, so be it a few bytes of storage in memory or on disk. It's a resource utilization of sorts. So it is expected that accounts will sort of be paid for by the owner of the account. I don't know the exact amounts, but they are going to be extremely low. And if you proxy, chances are that you will earn more back from whatever the cost of holding an account is. But the point here is that an account will auto-renew itself for the period specified by the auto-renew period and draw payment from its balance at that time. So if you create an account today for 6 months with a 6-month auto-renew period, you will be charged, or the fee for doing so will be 6 months worth of account existence. And 6 months from now, the account will renew itself for 6 months and will pay itself, or rather will pay Hedera, that 6 month renewal automatically. If the balance is insufficient, it will renew itself for however long the balance allows. So if, for argument's sake, it's 10 HBAR, that would be a lot, to renew an account for 6 months, and there's only 5 HBAR in the account 6 months from now, then the account will renew itself for 3 months. That's all it can afford. So its balance will go to 0. And then 3 months on, when it comes to expiry, because it's only renewed itself for 3 months, if funds have been added to the account, it will renew itself again. So it won't disappear. But on the other hand, if there are no funds and it can't renew itself, then it will delete itself and will be marked as deleted and will eventually disappear from the network altogether. So we have a number of sort of transactions that can affect a crypto account. The create transaction creates a new account on Hedera. And the only 2 pieces of information that are required in order to create an account are a public key and an initial balance. So what that means is that if you want to create an account, or if you want an account created, it has to be created by, or the transaction for doing so has to be executed by another account holder on the platform, because the sum balance needs to be transferred into that account, however many tiny bar, and the transaction for creating the account has to be paid for, and that initial duration of the account, be it 6 months, 3 months, or 2 hours, also needs to be funded. So an account is required in order to create another account. You do not create an account on Hedera by simply getting a public key and then claiming it to be your account. You need to run through a transaction from another account. All the other parameters can be set if necessary. So the thresholds and so on and so forth are defaulted. But if you wish to override them at the point of account creation, you can do so. The delete transaction is the counterpart to create. It deletes an account on Hedera. It's fairly straightforward. If there are any HBAR left in the account, you can specify, well, you have to, otherwise the transaction will fail, the account to which the HBAR should be transferred to. The account will be marked as deleted, but not physically deleted. That will happen when it eventually expires. And why is that? Well, you may want to prove that your account was indeed deleted. Hey, you know, I did delete the account. Here's a state proof. Well, you can't get a state proof for something that no longer exists. So the state proof will be account XYZ is marked as deleted. So Hedera validates that the account is indeed deleted. And that's why it remains in the ledger until it expires, to give you a chance to get that state proof. It can no longer receive transfers. It can, however, be extended while deleted. So if, for whatever reason, the account has been deleted and you wish to extend the duration of the metadata of the account being stored on the network, you can extend that expiry date, and it will remain in that sort of provable state of having been deleted for that extended period of time. Transfer transaction, again, fairly straightforward from the outset. transfers hashbar from one account to another. It has very low fees. It can enable micropayments, which we've covered earlier, and you've seen with the, or hopefully you have, with the daily timestamp demo. But what's maybe hiding under the covers, and if you use the SDK, you may not have noticed it unless you sort of looked at more of the detail of the SDK. The transfer list in the transaction itself enables multiple destinations and sources to be defined so long as all amounts add up to 0. So out of the 4 panelists here on this call, Greg, Andrew, Andy, and Simi, if Simi was feeling generous and she had 9 hbar to split amongst the 3 boys on the call, she could send 3 to Andy, 3 to Andrew, and 3 to me in one single transaction. She would just have to write her transaction in such a way that the transfer list says -9 for Simi, +3 for Andy, +3 for Greg, and +3 for Andrew. She could equally send 7 to Andy, 1 to Andrew, and 1 to Greg. Or both Simi and Andy could be sending 5 hbar each to Greg and Andrew all at the same time, all in one transaction. So wherever you've had previously a requirement for a smart contract to handle multi-party payments, this can be done with one single transaction at the speed of consensus and with very, very low fees compared to running an equivalent smart contract on using native crypto payments. The transfer list, I believe, is limited to 10 accounts in total, or 10 transfers. Yeah, there is a limit there to 10, but for most use cases, that should be plenty enough. You can transfer to the same account, so there's nothing to stop you from transferring funds to yourself. And you might be thinking, well, why would I want to do that? You could use the memo field of a crypto transfer transaction to carry some data and have it run through the network and get a state proof to say that that particular data existed at that particular point in time. So if you put this on the back of a crypto transfer transaction and you put a memo that has, you know, Greg was here type of message, whatever, and you transfer 1 hbar to yourself, then your balance won't be affected, save for the fee that you would have to pay for the transaction. You will be able to get a state proof for that particular transaction, and therefore prove that that data existed at that given time. You can also transfer 0 tiny bar, so you could transfer 0 tiny bar to yourself or to anyone. You just paid a transaction fee, and that's perfectly okay. So again, thinking outside the box of how you can use the crypto transfer API to do things. Being able to transfer 0 or transfer to the same account does have some interesting possibilities. Claims. So again, this is a feature of accounts. Accounts have claims, and a claim is a hash of a document or a hash of something. It can be anything you can think of. The list here is by no means exhaustive, but it could be a scan of a passport, it could be a driving license, diploma, anything, a property deed, whatever you want. It's attached to an account via an add claim transaction, and it can be deleted from the account via a delete claim transaction. So why is a claim interesting, or why is it useful? Well, say, for example, that you have a diploma, and you need to prove to somebody that you do indeed have that diploma, but you don't want to show them the diploma itself. What you can do with a claim is you could get the university that issued you the particular diploma to get a hash of that diploma, store it on your account, through an add claim transaction. And then they could transfer the hash of that diploma to the third party that's interested in knowing that you have the diploma without transferring the document itself, and say to the third party, well, you don't have to trust this particular individual to give you the right information, but you can trust us, the University of XYZ, to be a decent standing body, and we guarantee you that this document with this particular hash is indeed the diploma that belongs to so and so. And you can check their account on Hedera Hashgraph. We validate, and our key, our public key, is associated with this particular hash. We validate that this document is indeed theirs. So you can perform a query on Hedera Hashgraph called getClaim. You give it a claim hash, and that will either tell you whether for a given account ID or account reference. And that will indeed confirm that this particular hash does exist or not against this particular account. So that's just one way in which you can use a hash. There are plenty more, I'm sure. One thing to bear in mind is that a hash is mutable in as much as it can be deleted by any key that's associated with the hash. We'll talk about control mutability later on in respect to files and other things, where all the keys, and we talked about multi-signatures on accounts, where all the keys or a threshold list have to sign. In the case of a claim, if the claim is, for example, a driving license, then the driving license authority, so long as their key is associated with that claim, have the ability to delete that hash from your account or from an account. And that gives them the ability to revoke the credential or the hash from that account, which is why it's necessary to be able to delete with a single key that's associated with the claim. Not everyone can delete it, only those that have the private key associated with a key associated with the claim. So if my driving license is on my account, the driving license authority can delete it. I can delete it myself if my key is on there, but I can't then force that the driving license authority requires my signature in order to delete my entitlement to drive. That would be a file as opposed to a claim. Okay. So we've created an account. We've added potentially added and deleted claims to it. We may want to update some properties of an account, and we're starting to talk about or to look at some control mutability elements of Hedera Hashgraph. So more specifically, and I'll get back to keys in a second, you can change who you're proxying your coin to. If you decide you no longer like this particular node, you can proxy to another. You may decide you're generating far too many records for the thresholds, or that you want your account to renew every month instead of every 6 months, or that you want it to expire in 10 years from now as opposed to 2. So all of those can be updated with an update transaction. But equally, you can change the keys on the account. So remember, an account is created with one or more public keys if it's a multi-sig account, and it may be necessary to change the signatories on the account. It may be necessary to change the keys associated with a given account. So you can do that with the update transaction, and essentially the transaction would need to be signed by the previous key holders. So it would have to be valid per the previous key holders. And it also has to be signed by the new key holders. So why is that? Well, if there is significant cryptocurrency in the account and you're switching the key holder from myself to Simi, I just transfer my account to her, and there is a lot of cryptocurrency in there. But let's say, for example, I've miscopied or mistyped the public key that Simi's given me. If she wasn't signing for that transaction and I was the only one to do so because it's my account, and I sent it onto the network, the public key would be updated, and then Simi would try and transfer some funds out of it, and the network would say, well, your private key doesn't match our public key, and the account is therefore stuck, and the hashbar is lost. So any change of keys, and this will apply to files and smart contracts moving forwards, or as we move through the presentation, any change of keys requires signature from the previously authorized key holders and the new key holders as a safety precaution. Right, queries on accounts. Get balance returns you the balance of an account. Simple, straightforward. Get records will return records held against an account up to 24 hours. If you've set your record, your generate record threshold to a given amount, and you've received, set your receive record threshold to 10 hashbar, and you received 200 hashbar transactions or crypto transfers into your account, then that would have generated 2 records, and get records will allow you to get those records from the system. With or without a stay proof, that's up to you. But they will only exist on the network for 24 hours. So you kind of need to get them at least once a day or something, else they'll get lost. Or mirror nodes will have to provide a service whereby they're stored in some way, shape, or form. Get claim, I've covered briefly earlier, allows you to check whether a claim exists against a given account. So that takes a claim hash and validates that the hash does exist against an account. Get info gives you all the information or properties of a given account. And get stakers gets you the list of accounts staking coins on that particular account. So I guess that's fairly straightforward too. Although this may be one of those queries where you want to do a get cost first, because if there are 10,000 accounts staking to one given account, the response will be fairly large, and presumably that query may be fairly expensive, relatively speaking. So just to mention, get records, if you're jumping to try this on testnet or mainnet, this isn't enabled at the moment. Claims are not enabled on testnet either at the moment, and get stakers isn't either. So all of that, a lot of that functionality will trickle through sort of between now and OA. But I'm giving you everything that I know is planned or coming in this session. Not much point in not covering it. So a crypto create transaction body. So we've looked at we talked about crypto create earlier. So we need the public key or keys of the new account, the initial balance, the account that we want to proxy to. This is optional. Send and receive record thresholds, again, all optional. Is the receiver signature required? Yes or no, that's optional. The auto renew period, so 3 months, 6 months, 2 days, 6 minutes, whatever you want. The shard and the realm in which to create the account. And I don't know if you were all here earlier when we talked about realms. One question was, can I create a new realm myself? And the answer is, yes, you can do it here. If you specify a realm ID here, which is not 0 or -1, sorry, which is not 0, and you specify a new realm admin key, which allows you to administer your realm, then a new realm will be created. Now, this isn't available on testnet and mainnet today. It will be, it will be available moving forward. I've just told you a lie. I've just looked at my notes. If the realm ID is null, then the admin key for the new realm here will apply, and a new realm will be created, and you will get a realm ID back from the network. Else this would be saying, sorry, create an account in shard ID 15, realm ID 5, and the new account ID would come to you. But if you specify a null realm ID or a realm ID other than 0, then a new realm will be created for you. Okay, and return to you, obviously, so you can then manage it. But I have no visibility on when realms will become available, so I'll save you that question for the chat. Crypto transfer. So how does a crypto transfer message look like? So it's a message that's made up of account amounts, which is an account ID and an amount. And a transfer list is a repeated account amount. So you can see how we can do these complex transfers where we can transfer, as an example here, -10 from account 1010, +5 to 2093, and +5 to 2883. So that's where maybe Andrew and Andy are feeling, sorry, Andy is feeling generous and he's paying Andrew and Simi in one single transaction. So that's crypto transfer in detail. Crypto at claim contains the account ID that we're attaching the claim to, the hash of the claim, and the list of keys that is allowed to essentially manage the claim. Now, managing the claim is quite simple. You add it, and then you can only delete it. You can't update a claim. The only way to update a claim would be to say your driving license has been renewed and has a new expiry date. You would have to delete the original, and you'd have to add the new one. There is no update on the claim.